Hi everyone, I am Bindeshwar from Post Network Academy, and in this video you will know two properties of arithmetic mean which are very important. So the first property is that sum of deviations of observations from their mean is 0. That means summation over from I1 to n xi x bar that is equal to 0. That means it is a mean and xi are observations. And if you subtract observations, mean from observation, that would be deviation. And if you sum, so that would be equal to 0. Now we will prove it and we will see an example. So let us see proof. So that means from 1 to n xi x bar, we have this expression. This expression we have. Now let us open the bracket. So that would be equal to summation over from I1 to n xi minus summation over from I1 to n x bar. Now let us see this term. So you can take x bar outside from the summation because x bar is a constant. So again I am writing this expression summation from I1 to n xi and this x bar summation from I1 to n, and if there is nothing so you write 1 and thereafter write this term n because summation of 1 n times would be n. So again you can write this expression from I1 to n xi minus x bar and that is the n. Now see that again I am writing because x bar and you should write n x bar. So summation I1 to n xi minus n x bar. Now this expression. Now again see that here. Now consider this term. So if you see the average, so average is equal to summation over x's I1 to n and upon n. This means that summation over I from 1 to n xi is equal to nx bar. So you can see from this result you can write this expression as nx bar, and second term is already nx bar, and that would be equal to 0. Now let us see an example. So I'm taking some data 2, 4, 6, 8 and 10. So if you see, the mean would be 6. So x bar is 6. Now take the deviation, that means 2 minus 6. Subtract mean from all observation, that would be deviation. 2 minus 6, 4 minus 6, 6 minus 6, 8 minus 6 and 10 minus 6. This. And if you subtract, so that would be minus 4, that minus 2, that 0, that 2 and that would be 4. Now see that, so that would be equal to minus 4 minus 2 plus 0 plus 2 plus 4, and if you observe that, that is equal to 0. Now let us see another property. Second property, I am writing property 2. So it says that sum of squares of deviation. Remember that sum of squares of deviations taken from mean is minimum. Is a minimum comparison to the same taken from any other average. So here any other average means that may be geometric mean, median, mode and also harmonic mean. So the deviation of squares of deviations would be minimum if it is taken from arithmetic mean. So let us see that. So suppose that I am taking deviation from other averages, and that average is A, and square it. Now I can write the same expression is xi here. Don't forget to write summation from I1 to n. So xi minus x bar plus x bar minus a and square. So the expression you can write again, summation xi minus x bar whole square, and of course I from 1 to n, plus summation from I1 to n x bar minus a. So, and that would be square plus 2 plus 2 summation over I1 to n x bar minus a, and the second term is summation over I1 to n x minus x bar. Now if you observe that, so that term would be equal to 0. So the whole expression that would be equal to 0. So you will write whole expression is summation over I is equal to 1 to n xi minus a a whole square is equal to summation over I 1 to n xi minus x bar whole square plus summation over I 1 to n x bar minus e whole square. So we have this expression. Now let us observe this expression. So let us again write this expression. So in the left side it was summation over I is equal to 1 to n xi minus e square, and in the right side summation over I from 1 to n x I minus x bar whole square plus another term summation over I 1 to n x bar minus a whole square. Now let us transfer this term into left side. So you will have summation over I 1 to n xi minus a whole square minus summation over I1 to n xi minus x bar whole square, that would be equal to summation over I1 to n x bar minus a whole square. So you can see that this is your observation, all observations, and that is other average. I'm writing other average, and that is also observations, and that is mean. So see that the property is that if you take deviation from other average, and if you take deviation from the mean, so that would be minimum. Why? Because if you subtract, so you can see that there is a positive quantity because you are taking a square, so that would be positive. Even average is negative, so that means that this one is less than this one. So that is the minimum. If you take any one, so always this quantity would be less than. That is a minimum. Even when it would be equal, you can see that if the value of E is equal to x bar, then that term would be 0. That means then both term would be equal. So you can say that. Now you can see that I have written here. So here it means that that is greater than this term. So that would be greater than or equal to 0. And see that it would be equal to 0. That means both would be equal if x bar is equal to a. From this term you can see that. And that part would be 0 and both terms would be equal. So that means if you take deviation from other averages, and if you take average from the mean, so mean one would always be less than the average deviation you have taken from other average. So this was about sum of squares of deviation taken from mean is minimum. So this was second property of mean. So hope you understood. In upcoming videos, I will again continue the central measures of central tendency series or averages. That is very important for statistics itself, data science and artificial intelligence. These things are basics, so you should understand it. So in this video, I have explained two properties of arithmetic mean. Hope you understood. Thanks for watching the video.